Go. All right. Oh,
71 people?
yep. There we
Okay.
go. Hello, everyone. Thanks for joining us. Getting started in a few minutes. All right. Couple more minutes and we'll get started. All right.
102.
What's that?
It's 102 right now. 3 more minutes?
Yeah, yeah, just a couple minutes. Where are we at? What, 81? All
Oh, yeah,
right.
81 now. Yeah, 81.
Yeah, great. Getting there.
And really, it can't drop the file for whatever reason. I don't know what happened.
I'm back, Joby. I got logged off. All right, everyone.
Yeah,
Thanks for joining us. Thank you for being here. One thing, real quick, before we start our training, I just want to talk about next week's chapter meeting. We're going to have it at Alhambra Room at LA Public Works facility as our usual spot where we have in-person meetings. That's going to be from 11 a.m. to 2 p.m. We're going to have training, 2-hour training with John Caparelli. He's going to be covering his structural fundamentals for residential wood frame roofs. Um, we'll drop that link in the chat if you're interested to join us next Thursday. Members, it's $20 for members and $30 for non-members. So come out and join us for our last in-person training with John Caparelli. Now I'll hand it over to Grant. It's all you, Grant.
Cool. Thanks so much. Great to be here and giving some training on the ICC CalGreen EV charging. I work at 2050 Partners. We're a consultancy who advocates for more efficient building codes and appliance standards. And as part of that work, I work on decarbonization, and some of that involves EV codes and how buildings can be better stewards for EV charging. And so this is an overview of uh, some of those components to the code. So first, I'm going to talk about the CalGreen process and how that works. I'm going to talk a bit about changes from the last CalGreen code cycle, and hopefully that'll also kind of give people who aren't familiar with it at all some sort of baseline, and then go over some examples, talk about automatic load management systems, and yeah. So without further ado, I will get started.
Uh,
Yeah.
Grant, real quick, sorry. I should have mentioned that next week sent to you, and Grant gave us permission. We'll be sending out the slides as well, just so everyone knows. You don't. Everything will be sent out next week, and the recording will be put on our YouTube channel. Thanks.
Yes, the slides will be sent out. Thank you. So yeah, first off, there is just the California Building Standards Code, and that's in 12 parts. Most of the EV charging code is in part 11, and that is called CalGreen. The Building Standards Commission oversees the whole process of adopting this code, but they also propose code. So there's the Building Standards Commission, and Community Development, the Department of State Architects. They all propose code, and the Building Standards Commission adopts the code that goes into CalGreen. A lot of the EV measures are in the Chapter 4 and Chapter 5 residential and non-residential mandatory measures. Some of those terms that are used in there are defined in the definitions chapter, and that's pretty good for seeing specifics about a term that might not be super clear. And there's a lot of terms that aren't super clear in EV charging, just because it's such an unfamiliar space for a lot of people. In addition, there's Appendix A4 and A5, and those are voluntary measures that can be used for cities who want to have more stringent EV charging measures or other kinds of measures, but I'll briefly go over the voluntary set of measures that's used for the voluntary that can be used in addition to the mandatory measures. And these are just more charging spaces generally for parking lots. The California Air Resources Board is also authorized to provide proposals for CalGreen, and they're pretty active in the EV infrastructure proposal section. So that's been going on for over 10 years now, and they're pretty active because they have a mandate to reduce emissions in general. So this is the 2024 code adoption cycle. They call this the cigar in the Building Standards Commission. We are at the very end of it, basically. So the initial submittals have happened, initial public review, workshops with all the state agencies. We're right about at the end of the line. So on January 1st, 2026 is when the new building standards code will be adopted and mandatory. So between the publication date, which was July 1st, and January 1st, there's a statutorily required 180-day period. And during that time, there's time for review so that building officials can understand it better, but there's no changes that happen after that. So in about 2 months is when the 2025 California Green Building Standards are going to be updated and used. And then after the big triennial code cycle, there's also an intervening code adoption cycle. And this is used to try and clarify things, to try and make sure that there's issues that can get ironed out, so that if there was a big problem in the previous adoption cycle that is stumping building officials, that can be ironed out. So we are just starting that, and we're basically at the end of the beginning where the state agencies submit proposed code changes. And this is going to be going on for about a year. So next August-ish is when the publication of the initial submittals and the initial proposals is due. And then similar to the last cycle, it'll be effective on July 1st of 2027 and published on January 1st of 2027. So about a year and a half between the previous code and this new code. And this code I'll talk about a little later. There's not really any changes that are going to be happening that are significant. There's just a couple of little addendums that are addressing issues that building officials are having. In addition, the state assembly passed Assembly Bill 130, which includes a moratorium on residential building standards from being increased. So that's going for 6 years, and basically there's not going to be any more anything that's going to get more stringent during that time. So you can look forward to a pausing of the building code for the next at least 6 years. We'll see what the assembly does, but unless it's clarifying, there's not going to be anything changing to the residential building code. The non-residential building code still has some opportunities for change, but residential is staying the way it is. So yeah, this is the beginning of the actual code. For new construction in non-residential during the new changes, there was no increase in the total number of EV spaces. So whatever was in the 2022 code, that's what's going to be in the 2025 code, or 2025 code published starting 2026. And I'll show that actual chart later. There is a new type of building that's called office and retail, or two different types of building, office and retail. Previously there was a total number of EV spaces, and in those spaces there's a thing called EV capable. This is going to be newly the number of actually installed spaces with EV charging is going to increase by 2 times for most building types and 3 times for the office and retail sector. The third big one, which is huge, is the new J3400 connector, which is also known as the Tesla connector or the NACS connector, North American Charging Standard. So that's specifically called out as chargers can have that connector. And then another little part of the code is that if there's raceways installed, so not actual EV infrastructure or EV chargers, the size of that is increasing to accommodate future 40 amp branch circuit conductors. I don't know the previous size, but it's increasing the size so that chargers can be higher power without having to do a bunch of tear out of the current infrastructure. For multifamily, the the coverage used to be 40% of units or parking spaces had to have an EV charger, and now it's at least one charger per unit. So every single unit has to have at least a low power level 2 space, if not higher. And if there's parking lots that aren't connected to the actual building, so say you're in a condo complex and you have assigned spaces in those parking lots, the EV space has to connect directly to the breaker panel. So there's easier billing for multifamily units, and there's some exceptions for if it's an infeasible ask to do that. And then additionally, similar to the non-residential, the number of EVSE installed spaces increased from 10% to 25%. And a big one that I'll talk about later is automated load management systems. So these are systems that kind of take all of the aggregate EV charging demand and even it out so that you don't have to have as high total overall charging capacity while still being able to charge the same number of vehicles. And then there's a hotels and motels category that's been split out as well. And this one is staying at 40% spaces that have to be low power level 2. So the 100% for multifamily is not going to be applicable to hotels and motels. And then similarly, EVSE installed spaces increased from 10% to 25%. Please feel free to ask questions at any time, and I'll try to answer them while I'm on the slide. But if something comes up later, let me know, and I'll answer it. But I will continue on to the highlights for altered or added parking spaces. So on the left side, there's the non-residential aspect of this. There was a possibility that when a non-residential building was adding EV charging stations, they would bypass whatever existing allocated power and infrastructure were already there and just trench new holes, add new conduit, new cable, and then install the EV charging there. This code change, basically, if there's already allocated power and infrastructure for EV capable spaces, that has to be used before you add new EV capable spaces. It's kind of a getting a loophole closed that prevented more EV charging from being installed. On the multifamily and hotels motels side, that's a uh, pretty similar change. It's just the wording was changed. So each parking space added or altered shall have access to either a low power level 2 charging receptacle or level 2 EV charger. And so anytime there's work done that adds parking spaces or adds solar charging over parking spaces, there's this new alteration clause that's going to be triggered by the building code. And there's that exception at the bottom that where work requiring a permit is just in where work requiring a permit is being performed for the installation of a 120-volt receptacle for EV charging. So if you're installing a receptacle to do level 1 EV charging, you don't have to then install a level 2 EV charger. As just they recognize that some people are going to be installing level 1. Speaking of solar parking, there was quite a big, this is the only change in the intervening code adoption cycle that I was talking about earlier that's related to EV charging. There was a question and a lot of confusion where if a parking lot, say, had 100 spaces and they added 10 parking spaces to that parking lot that had solar, like a solar cover over those parking spaces, people were confused if all 100 spaces had to now count towards that EV charging requirements, or only the 10 EV charging 10 spaces would be counting towards that EV charging requirement. This is clarifying that only the spaces that are newly covered with a solar cover, new photovoltaic system, count towards the EV charging requirements. The Building Standards Commission doesn't want people not installing solar because there would be an increased cost from EV charging. So this is clarifying that if covered parking is newly covered with photovoltaic systems, only that newly covered parking space counts towards the EV charging requirements that I'll talk about a little later. The requirements that are how many spaces need to have EV charging. Speaking of EV charging, EV ready, EV capable, this is the whole diagram. So it goes from the transformer to the meter to the panel to the circuit outlet and then the supply equipment. So this is an EV SE, EV supply equipment or an EV charging station. And there's three kind of levels of readiness that they have defined in the code. The first one is EV capable. So this is what I was talking about earlier with the non-residential having to use previously installed EV capable spaces before installing new infrastructure. If there's electrical panel capacity and conduit already installed, that's what an EV capable space is. But there's nothing above ground that indicates that an EV can be charged there. So that next level is EV ready, where the conduit's installed, the wiring is installed, and there's a receptacle, but there's no actual EV charger installed. That's called an EV ready parking space. And that's kind of a lot of there's the circuit overprotection, there's the receptacle, but it's still, you can't plug in an EV into that EV ready parking space. And then the 100% ready space is called EV installed. So there's the panel, the wiring, the outlet, and the outlet either has, or the receptacle either has the supply equipment plugged in or the supply equipment is hardwired. So that's hopefully a little helpful for understanding what a parking space can have in it. And here's some examples of the pictures. On the left is an EV capable space. You can see there's empty conduit with white. Well, you can't see that the conduit's empty, but it's empty, and there's a panel capacity for that charger. The second column is a low power level 2 receptacle. So it's not the NEMA 1650 that can handle 50 amps. It's a smaller 20 amp circuit, 60 amp charging capacity that can do low power, but still higher than a trickle charge from a 120 volt. And then there's the charge point kind of that's pretty common in retail store or retail parking lots. You have your level 2, that's a 40 amp circuit and 32 amp charging capacity that terminates in an EVSE. So the EVSE is there and someone can walk up and charge their EV. And then there's the DC fast charger, which is much higher capacity, 30 to 50 to 350 kVA, and 480 volts. So EVs have an onboard charger that converts AC to DC current that uses the level 2 EVSE's supply, or level 1. A DC fast charger has the inverter on the charger, and that directly bypasses the onboard charger and starts charging the battery. So it's a little more efficient at the cost of the charger being much more expensive. So since 2022, the like I said, the number of EV spaces didn't change. Between then and now, the number of actual EV charging stations installed has increased. So the the middle column is the number of required EV capable spaces, and the right column is the number of EV charging stations. And this has increased since then. So I think on the next slide, there's on a future slide, there's the new column, or new table. And then on the right side, this is showing the changes. So if you have 1 to 9 parking spaces, there has to be at least a level 2 EVSE or DC fast charger and at least one level 2 EVSE. So no matter what, there always has to be at least one level 2 EVSE installed. And there's this whole new method for calculating how many charging spaces need to be installed called the power allocation method that I'll go over. And that's a new requirement. It's an alternative to having this table where you look at the number of spaces and then you just see there need to be 13 EV capable spaces for a 51 to 75 space parking lot. This one, you take the number of spaces and multiply it by a power number, and then you can divide the power however you want. So I'll show that a little later. Yeah, so any questions so far, feel free to drop them in and I'll keep moving. Like I said, in non-residential, there's the new power allocation method, and also the part of the space method is that if you have 5 level 2 EVSEs or 5 EV capable charging spaces that are required, you can then replace that with just one DC fast charger. So similar power availability for vehicles, but not as many chargers, which can be good or bad depending on the use case of the vehicles that park at the parking lots. And then also there's if you have an EV capable space, so EV capable is the space that just has the conduit, you can choose to instead install 2 low power level 2 EV charging receptacles as a replacement for that. And then the third bullet point, talking about existing buildings being modified. So I talked about this already, so I'll skip this, but this is the solar parking coverage changes that are happening in the intervening code cycle. This next slide is a screenshot from the code, and I'm just going to walk through it a little bit. This is the non-residential EV spaces required. So this can apply similarly to the residential code if you're looking at a similar table, but in multifamily, there has to be one charger per unit. So you can't really, there's a much lower percentage on non-residential buildings. For example, this we'll just walk through. If you have a 20 space parking lot in the current building code that will be released on January 1st, 2026, at least 4 of those spaces have to be EV capable, so the conduit. Um, if you are office and retail, 3 of those 4 capable spaces have to be EV charging stations. So they have to have the full EV supply equipment installed, and an EV can drive up and start charging. If it's not office and retail, only 2 of those 4 have to be EV charging stations. So that math, previously, this middle column was a bit lower, and this middle column has doubled since 2022, the required number, and the right column has tripled since the 2022 code. And if you have a parking lot over 200 spaces, you just calculate by the percent of how many parking spaces there are. So if there's 400 parking spaces, 20% of those, or 80, have to be EV capable spaces, and then continue on down the line. If you don't want to deal with the EV capable spaces and finding conduit further along the line, so you you're in office and retail and you see you need to have 3 chargers and 1 additional space, you can instead just install 4 EV charging stations. And in this bullet 2, or sub bullet 2, there's each EV charging station shall reduce the number of required capable spaces by the same number. So that's just saying if you go up to 4 here, that's reducing this number by 1, and then you only need you can basically install EV charging stations to replace capable spaces and not have to be penalized for thinking ahead with or planning ahead with more charging stations than are required. Talking about the power allocation. So this is the other method for calculating how many EV chargers you want to have in the parking lot. The space allocation method is pretty straightforward. This is a little more mathy. So you start with the number of parking spaces you have. We'll start with 10 to 25 again. You multiply the number of parking spaces by 20%. And that 20% then gets multiplied by 6.6 kilowatts. So that's basically a 40 amp circuit, 80% continuous duty and 208 volts, which is like a baseline level 2 EVSE. And that's your minimum total kVA required for the parking lot. And from there, you can fill it out however you want. So you could have a bunch of 3.2 kVA chargers, or just one 26 kVA charger. The only caveat is that you have to have 1 level 2 EVSE. So even if you just have one 26 kVA charger, there also has to be a level 2 EVSE. And then the other caveat is that EV capable spaces can only be 75% of the required capacity. So in this first column, 26 kVA, 75% of that can be EV capable, just the conduit and the panel, which is 20-ish kVA, and then the other 6 or so would be required to be an EVSE. And lastly, low power level 2 charging receptacles are an option now. So previously they weren't explicitly called out in the code as being available, but now they can be installed as a EV charging station option. And now I'm going to go over a couple of examples. So this is the first one. This is what's changed for non-residential mandatory levels. And nothing has changed. So if you have a 69 parking space lot, you need to have at least 3 level 2 installed and at least, what is this, 10 EV capable charging spaces in this non-residential building. So that's general code requirement, not a change for the triennial cycle. With the power allocation method, here's some examples of the same parking lot, but with different power allocated to different chargers. So 69 spaces, here's that math, times 20% times 6.6 kilowatts, you have 91.1 kilowatts. per the table that I showed you, would use 85.8 kilowatts. And then from there, you can divide it up however you want. So you could have 40% of them being low power level twos with, I believe that says 20% or 10% EVSEs, or you can have 25 or 15% EV capable and 5% EVSEs, as long as the total power adds up to 91 or 85.8 kilowatts, then you're good. So the power allocation gives you so much flexibility. Um, and here's another example. So there's a bunch of, you can have this 24 total EV spaces, you can have 18, 14, 12, 10, and just 2. So all of these meet the code, but they're just different allocations of receptacles versus EV installed versus DC fast chargers. So in the bottom middle and bottom right, there's a DC fast charger that takes up a lot of the power allocated, and there's just that one level 2 charger that's required. So yeah, that's the power allocation method. Pretty complicated compared to the space allocation method, but I think it's a lot of flexibility, and the DSA is planning on only using this for the Department of State Architects is going to use just the power allocation method for their planning. So they've talked about rescinding the entirety of the space method in their section of the code for schools and universities. This is also a new type of new addition to the code. So this is for medium and heavy duty requirements. This is basically to accommodate for futures where tractor trailers and refrigerator trailers are electrified. There's additional capacity required in the raceways and busways and transformers and panels that are needed for based on square footage of the building size. So if and also depending on how many off-street loading spaces there are. So for example, in a 10,000 square foot manufacturing facility with one or two off-street loading spaces, you have an additional capacity required for everything of 200 kVA. So this is just for the future when there's more electrified vehicles, you don't want to have to do that costly trenching and adding more conduit. It's just a future installation of medium and heavy duty charging equipment is the goal, and we don't want to just run into issues where the cost to install new infrastructure is so high that it's hard to deal with. So the code is trying to think ahead with making installations future-proofed a little bit. And then here's a link that you can click on when you get the presentation to go to the language that'll be active on January 2026. Most of what I've talked about is in there. There's probably quite a few exceptions and little nuances that I've missed, but yeah, for the most part, everything is in there. Like I said, I'll talk a little bit about automated load management systems. So this is in a case where a building doesn't have a lot of capacity to charge a lot of electric vehicles. So upgrading the transformer and getting the utility to come out is going to take a long time, take a lot of money. This is a system which can manage the charging to reduce the total combined electrical load while still providing the charging that's required. So in this example, we have 3 chargers that have 10 kilowatts available. Normally, if you had one charger, it was a 10 kilowatt charger, it would kind of hog all of that charge for just one vehicle. With ALMS, you can have the 10 kilowatt chargers, and they're all linked up to the same 10 kilowatts, but they are managed. That's the automatic load management part, manage to reduce their charge and therefore allow more vehicles to charge at the same time. So it's just a way to avoid infrastructure upgrades, avoid electrical system upgrades that is not as costly as it could be if we were talking about just maximizing chargers. Um, and so here's a more visual representation of the energy management benefits of ALMS. Um, the first, there's two benefits. One is capacity management. Because most buildings have limited capacity, there's not an unlimited capacity supply everywhere. We're trying to maximize the number of EV chargers when there's that limited capacity. So more chargers means that users don't have to move their car to share a charger. A lot of places will install just a few level 2 chargers that people have to rotate between. I know at my previous office, there was like 5 EV chargers for the parking lot. And everyone would go out at lunchtime and change their location of their car just so that other people could charge. So this is a way to reduce the biggest cost, which is increasing the infrastructure. And it also reduces the upstream capacity requirements so that basically there doesn't need to be a huge excess capacity available most of the time. And instead, the capacity is right sized because maybe in the future that building won't be there and there's a huge upgrade that had stranded assets or just lots of different options that could cause those upgrades to be to not pay out in the future. And then there's the energy management section of ALMS. So EV charging can be allocated based on a bunch of different factors. So if there's time of use rate charges, like demand charges, that can be alleviated. So if a building manager is paying for their electricity, ALMS could be helpful for that. There's also the opportunity for demand response programs from the utility to be activated. So if the utility has a program that lets vehicle drivers opt in to reducing their charging at times when there's peak demand in the grid, then that's definitely an opportunity for ALMS to be useful to drivers. And then also for carbon neutrality goals, the charging loads can be shifted to green generation periods, like the middle of the day when typically people are parked, and that way it can take advantage of all that sunshine. So this chart shows the same exact EV charging setup and the same exact amount of power delivered, but there's a peak in the one without adaptive charging, without ALMS at 150 kilowatts. And with ALMS, that reduces to somewhere around 80. This was from PowerFlex, and they're a great resource for adaptive charging and automated load management. So you can see the EVs all charge same amount of power, but just overall much less capacity required. Um, Here's a couple of reports that are summarizing kind of infrastructure requirements and infrastructure recommendations beyond just this current code cycle for reference. So if you have more interest in what's going on in EV charging, here's some information that'll be linked in the PowerPoint. Um, and then lastly, I'm going to go over an example of a parking lot with 120 spaces and a 208 volt transformer. So this is a real screenshot from the Port of San Diego going over, there's a 120 spaces. If we're going by the spaces table, that would result in 25 EV spaces. And from that, there should be 6 of those spaces have to have EVSE installed. And then 25 minus 6, you have 19 have to be EV capable. So that's the conduit and the panel capacity. If we go differently, if we use the power allocation method, the budget that has to be met is 165 kilowatts, so 20% times 120 times 6.6 kilowatts gets that 165. Of that 165 kilowatts, no more than 75% can be EV capable, which works out to about 124 kilowatts. So the other spaces need to be EV charging stations. Based on the fact that each space requires 30 amps and you have a 208 volt transformer, there needs to be 6.24 kilowatts per space. And that 124 kilowatts divided by 6.24 results in a total of 20 EV capable spaces. So in the space method, there are 19 EV capable required, or a minimum of 19 EV capable. With power allocation, you can have a max of 20 EV capable spaces installed. So one more, not a huge difference. And then on the other side, there's the no less than 25% of the power that has to be a low power level 2 receptacle or regular level 2 receptacle or DC fast charger. So if we're looking at low power level 2, that's 20 amps times 80% duty cycle times 208 volts, and that's 13 spaces are low power level 2 receptacles. If it's AC, 30 amp equipment, so slightly more than 20, but still pretty low, gets 6.3 kilowatts per space. And so there has to be 7 spaces that are AC EVSEs. And then if you want to use that 41 kilowatts for a DC charger, you can go up to 50 kilowatts and or start with 50 kilowatts, which is one of the smaller side EVSEs that is a DC fast charger, and that's one space. So lots of different options. There can be 13 spaces that are low power level 2, 7 AC EVSEs, or 1 DC fast charger. And that all meets the power budget that is required by the power allocation method, which is just one of the alternative method to the space allocation method. So either of these are valid. It's just that the space method has been in use for longer. Yeah, I blitzed through that. So thank you. And if there's any questions, please chat and I can hopefully answer them. And if not, get back to you. And I have some more examples of ALMS if there's no questions, but I can keep going.
Okay, great. I don't see any questions in the chat yet.
Okay. Well, then I will talk briefly about automated load management system. So a little more from
Okay.
this ALMS section. Just to briefly go over like a real world example. So this is 48 amp continuous single current across 5 charging spaces. So the example, we have an empty parking lot at 6 a.m. and the fleet is all charging at 9 p.m. So yeah, this is a fun little graphic that my coworker helped me make. And so there's 5 spaces and we start at 6 a.m. The what's happening at the beginning is here, and yeah, so I see a question, so let me answer that first, before I go over this. The ADA space question is not part of CalGreen, so I don't know the answer to that, but I believe that there's something related to 1 and 4. I don't know the source of that, but I can look into it and get back to you. I know that's an important question because ADA spaces are so different than a standard parking space, so let me get back to you. Sarah's question about what happens when some jurisdictions don't consider EV charging spaces as parking stalls. I don't know. Can you elaborate a little more? I'm not sure exactly what you mean by parking stalls versus EV charging spaces.
You should be able to unmute yourself.
Hmm.
You should be able to use it now.
Yeah, I will keep going and read
Yeah,
the
maybe
chat
we'll come
when it
back to
gets.
that.
Yeah. Um, so this is the beginning of a day. 7 a.m. There's one space that's taken, and you can see that it's got all of the panel capacity there. Um, and this is what would happen at a regular EV charging space with no ALMS because there's just one vehicle. But then a second car comes in and the ALMS takes that 48 amps and splits it evenly between the two. So space one and space three both get 24 amps. And um, another hour pass and another car comes in, and so it splits that into three. So there's three EVs all getting 16 amps per space, which still adds up to the 48 amps that the panel has. And there's also an opportunity with ALMS where uh, if a car is getting close to its full capacity, it can then tell the EV charging station that it's getting full and it can have its current reduced. So in this situation, the EV the first one that came in on space three is now getting a little less current, so it's getting 10 amps instead of the 18 that it was getting, and the extra is being split between the two other spaces. And then we can see that the first one is completely full now, and so a fourth one comes in, splits that current similar to how it did previously at the 9 a.m. mark. And then the same thing happens at the next hour. So the second one that came in is getting close to full, so it drops its current down to 8 amps. The other two spaces get 20, and that's how ALMS works, and it keeps going until everyone's happy and everyone is fully charged. And if the spaces don't need the full capacity, like there's only one car in the parking space and it's at 90%, then that's totally fine for the ALMS. It can just charge at 10% or 10 amps. And we keep going throughout the day. A new space is filled with a car that needs most of the current, so it gives it 40 amps, and the other one gets 8 amps. And then what happens at 5 p.m. is, sometimes a visitor comes in, sometimes the time of use rate increases, so the electricity is more expensive. And in this case, and if you know, or if the ALMS knows that charging doesn't need to happen immediately, it doesn't need to fill up completely, then you can delay charging. So in this case, the three vehicles are delayed, and um, that's great because it decreases costs without increasing any actual infrastructure build out. It's just a software change. And then we have another hour goes by and there's just still the one vehicle being charged. Once that fills up mostly, it gets full and there's less capacity needed. And so the other three vehicles can start charging at a higher rate instead of the zero that was previous. And then the capacity gets split again. Yeah, so you can see this is pretty standard. It's just a basic math problem, but it allows the capacity to be decreased overall while still feeding the same amount of current that might be required to charge the EVs. I'm reading this question. Some city will not require EV stations within new commercial building project and give clearance to the builder to not include EV spaces. So based on my reading of the CalGreen code, if you're a commercial building that's in a category that's covered by CalGreen, I don't think there's clearance to not include EV spaces. There's some exceptions that allow for if it's like extremely prohibitive to build because the cost is so high or something. There's some exceptions, but they have to be vetted, and I think the exceptions are not super lenient. So it's like if you're building a new city in the middle of nowhere where there's no infrastructure, that might be allowed, but I don't think there's much leniency if you're just a regular city building that has infrastructure available. I don't think you can get away with that. Amir's question, if a facility is required to provide one fast charging station and 5 regular charging stations, which has to be accessible? That I don't think there's nothing in the CalGreen code that specifies that. There might be something in the ADA that specifies that, but I don't believe there's anything in CalGreen. And also there's no requirement that there has to be a fast charging station. There's only a requirement that there has to be at least one level 2 charger. So that's the like 40 amp-ish, 6 kilowatts chargers. So hopefully that answers your question. The accessibility question is not part of CalGreen, but maybe it would be helpful for me for the next presentation to look at the ADA requirements so that I can have that ready to go.
And for Sarah Ramsey, she could unmute herself now, I believe, if she wanted to.
Yeah. Can you hear?
Yes.
So my question was, some jurisdictions consider an EV charging station not a parking stall. And say you have a TI where the use changes and the parking count increases, and then your ratio of EV charging stations changes, and you're left without capacity on your site to address sort of both sections of the codes because you're not allowed to necessarily double dip, et cetera. And so this might just be a question for the specific jurisdictions, but I was curious if CalGreen had any specific guidance on that.
Yeah, I definitely need to dig into like the difference between a charging space and a parking stall. But I know in CalGreen, um, if the parking capacity is increased, you run the calculations again on just that new parking capacity. So the EV space method or the power allocation method, this only applies if there's an alteration to the new parking spaces that are added. Or alternatively, if there's like solar parking covers added, only the spaces that are covered by the solar parking have to have this calculation, so you don't have to dig up the whole parking lot.
Right. Well, thank you.
Yeah.
I have a question actually, if you have
Yes.
time. Yeah, what about if they have a commercial building that specifically sell like individual for the owners per space to do like, for example, vehicle storage? and it's owned by the owner. Is this site required EV station or exempt per, I mean, because of the use is not for public, mainly is going to be for owners to occupy it or use the storage to store their cars.
So you're saying like a storage unit that
Self
has working spaces, kind of?
self storage.
Yeah, self-storage. Okay.
For cars, like they have unique car or expensive car, they typically buy space, not like rented, and there's no option for the public to visit or something. Is that required in this case?
Right. I believe I'll get back to you on this, but I believe that it had that the like you said, if it's not public facing, then the requirements are less.
Right.
But I'm not 100% sure, and I'll look into that.
I'm gonna post my email just in case.
Okay, yeah, sounds good.
Yeah, thank you.
Great. Any other questions? Happy to answer them, but I think we're getting close to the end.
Yeah, let's see. Any more questions?
Great. All right. Well, thanks so much for the attention, and hopefully you learned something or reinforced some learnings.
Yeah, yeah. Thank you, Grant.
Thank you, Grant.
Everyone, we will be sending out CEUs next week along with the PDF slides of his presentation. And hopefully see you guys at the chapter meeting next week, next Thursday. Have a good day, everyone.
Thanks.
Thank you.
Bye.
All right.